Okay, this is the third video I'm going to go through on how to do calculations involving reactions. This one has the trickiest stoichiometry so far that we've seen. But it has the same first step as the others, and again, slightly trickier, but we're going to work out the MRs. So the MR of the two compounds are interesting. So it tells us we've got the mass of the nitric acid, HNO3, and we need to work out the mass of copper nitrate. Cu brackets NO3, close brackets 2. So we're going to work out the MR of both of these. So HNO3, it's got hydrogen and 1 hydrogen times 1 equals 1. Nitrogen that weighs 14 times 1 equals 14. And oxygen, which has a relative atomic mass of 16 and 3 of those, which will be 48. So if I add those up, I get a molecular mass of 63 grams per mole. Now copper nitrate, slightly different. We've got brackets now. So copper, we've just got one of them. There's no number before or straight after the copper. So just one copper on my periodic table. Copper's atomic mass is 63.5. It might be slightly different on yours, but it should be around 63.5. Might be rounded up to 64 or 63. Somewhere in between there. So 63.5, just one of them. So that's 63.5. Now the nitrogens. Now there's no numbers before and after, but it's in this brackets, which are times by 2. So we times everything in the brackets by 2, and that means that nitrogen, that has a relative atomic mass of 14, we have 2 of them here. So that gets me up to 28. Now the oxygens, there's 3 of them, are 3 straight after the oxygen in the brackets, and then everything in the brackets is times by 2. So that gives me 6 oxygens, and they weigh 16 each. So 16 times 6 is 96. If I add that up, I get a molecular mass of 187.5. So that's my 2 MRs. Units of MR are grams per mole. So I'll just create some more space now. So now I've done that, I can go through my 3 steps to go from working out the mass, or from knowing the mass of the HNO3 to working out the mass of copper nitrate that will be produced in this reaction. So first up, step 1 is I can work out the number of moles over on this side. So 1N equals mass divided by MR. So 3.15 is my mass. Divide that by 63 to get 0.05 moles. Now then, this is a tricky bit with the stoichiometry, because the ratio is for every 8 of these, I get 3 of these. And so what I'm going to do to this number of moles here, to work out the number of moles over here, is I'm going to divide it by 8, and I'm going to times it by 3. So 0.05, divide it by the number on the left of the ratio, and I times it by 3, which gives me 0.018, and I go to 3 significant figures, so 0.0188 moles. However, I'm going to keep that number in my calculator for the next step. So to work out then my mass up here in step 3, mass is equal to the number of moles times the molecular mass, which I worked out earlier is 187.5. So I get here a mass of 3.52 grams. Again, I've gone to 3 significant figures and rounded up. Units are all in there correctly, and that's my mass of copper nitrate worked out.